No, I can edit them together. And we're back, everybody. Don't worry, no one died in the fire. We all survived due to our ability to solve conic sections. So we were just talking about how would we determine when one is vertically oriented or horizontally oriented, and I'll show you right here. This is an example of a vertically oriented hyperbola. Superbola. Well, how do we tell? Does anyone have any? Well, because the y fraction is the positive fraction this time, right? The subtract is with the x in this instance. So, so I'm not going to have you guys write down all these facts, but you can at least write down what the standard form for that guy looks like. I'll fit that down there. Bam, like so. That's good enough. So you've seen this before. This is also found in your book.
Go up a little bit.
Yep. Oh, definitely. Yeah. So yeah, the key difference to determine that is whichever fraction is positive. All right. So the y fraction is positive, so that's why it's vertical. Question, comment? Yep.
Wait, so the standard form?
The what?
Standard form. Yeah.
Yeah. Just like how for an ellipse we had vertically and horizontally oriented. That was based off of whichever denominator was larger. In this case, it's whichever fraction is positive. All right. So yeah, so that's what that looks like for starters. So let's see if we can get a couple examples done today. That'd be good.
Should we write down?
Wait, I want to write down the asymptote.
All right, yeah, I'll let you. All this stuff is in your text. It's just kind of like switched around horizontal to vertical. The only difference for the asymptotes is it's A over B instead of B over A now. The transverse axis is a horizontal line passing through the x coordinate of the center instead of a vertical line passing through the y coordinate. You know, all that stuff. And then the foci and vertices are similar to ellipses from what we've experienced before. And what's nice, like I said, this one is a squared plus b squared equals c squared to determine the relationships between a, b, and c for all of those distances. So let's jump into an example quick. Exemple. So here we are. If I wanted to giraffe the hyperbola, here we go. So this is, fortunately for us, it's in standard form. The first thing we should probably figure out is what's the center? So what is the center? Oh, that actually is a common mistake because in ellipses and circles, the x fraction came first. So yeah, the h is always the opposite of the number with the x. Yep. So 2, -4. So yeah, don't let that throw you off. That's definitely a possibility. Which way do you think this hyperbola is oriented?
Right.
It's vertical because the positive fraction is with the y, right? And just so you know, it's not because this is the bigger denominator, because it technically still could be vertical even if those denominators were flip-flopped. So it's vertical. Let's see, what's the value of a and b?
6 and 5.
A is the square root of the positive fractions denominator, which is 6, and b is the square root of the negative fractions denominator. So once again, untrain your elliptical thinking. It's not based off of whichever is larger. And then to find c, I can just do the straight up a squared plus b squared equals c squared thing, and I could plug in what I know, solve for what I don't. So 6 squared plus 5 squared equals c squared. So I'm going to get, that's an ugly 5, but that's fine. So 36 plus 25 equals c squared. That's what, 61 is equal to c squared? So c is equal to the square root of 61. And I don't believe I can break that down. So I now know a, b, and c, and I know the center. So I can now find the verts. Where's those vertices at? It's going to be a units away from the center in which direction? Let's see. Whoa, I'm getting some laggage. What? Yeah, it's not even writing it. It's so scared. It's like, it's okay, computer. I know I left you in the building during the fire drill. Oh, there we go. There's some vertices. Bam. Man, yeah, it's mad. It's a cranky
You
computer.
just need to cut me in the throat.
I didn't hear that. So anyways, so which direction am I adding A to? Which coordinate? The y coordinate, because this is vertically oriented. So 2 comma -4 plus or minus 6 would give me my verts. So those specifically would be 2 comma 2 and 2 comma -10. And then my foci, which there are 2 of those still, I'll add and subtract c to the y coordinate. So plus or minus the square root of 61, which is like 7.8 or 7.9-ish, I'm sure, something like that. So now that I have all of that, just like we did for an ellipse, I took the center and I add and subtract a to the direction that it was oriented. So that's why we chose y. And there's only 2 vertices for this one. The endpoints of the conjugate axis, we don't necessarily have to know. So to graph this, let's actually, I'll slide this aside, and I'm going to just get a nice little new sketch with a grid here. Here we go, grid form, square grid. There we are at, bam, bam. I'll hide those points. So let's see, I have to go how far? 2, 2, and 2, -10. And so it looks like something like that would do it. And so here we go. So let's graph it. So the center is at which point? It was at 2, -4. So over 2, down 4. Here's the center. I'm going to move A units up and down from this. So A units above it, put me right here. A units below it, put me right there. And so far, those are the only points on my graph at this moment. Move B units to the right and left from it, which these points are not on the graph. B was the value of 5. So let's see, 5 over would put me at 7 here, and 5 this way would put me at -3. And I'm going to draw the little box. All right. Drawing a box. And the reason I draw this box is that I'm interested in its diagonals, because those are my awesome totes. Right? So far, the only points that are actually on this graph are the purple points. So all of this work is just to figure out where this graph lives. And now that I have the purple points and the asymptotes, I would then draw this, and it's vertically oriented, so that's why it's opening upwards, like so. And it gets infinitely closer to those asymptotes, but never gets there. And if I wanted the foci, as I said, it was just a little bit less than 8 units away, so I think that was, let's see, was it, yeah, 6, so it would be somewhere here and somewhere here would be where the foci are, so that's C units above and C units below. So those are roughly where the foci are, so that's what a graph would look like. So it looks like we won't have time for our second example, but it's that's fine. It'll be familiar to you based off of your skills with circles and ellipses. But thanks for watching, friends. Have a great day, and avoid fire. Bye-bye.